Hi all, this is a final demonstration video for the Google Summer of Code project fixing bugs in BoneScript and improving BeagleBone user interface under the BeagleBone.org Foundation. The main goal of the project was to fix bugs and issues with the BoneScript library with the secondary goal of improving the browser-based BeagleBone user interface. The main goal of the project, fixing bugs in BoneScript, aims to fix all the reported issues for the library and add new features to the library which could improve the user experience. The issues reported has been classified into feature requests, suggestions and improvements to the code base, bugs and compatibility issues. A brief report of the project status is shown here. Now I will provide a brief description on the fixes made to BoneScript. Fixing the BoneScript PWM issues. These issues relate to fixing the BoneScript analog write function and providing better quality PWM signal when generated with BoneScript. The issues fixed under this category are smooth PWM output. Previously there were slight disturbances in the PWM output while sweeping the PWM frequency. This was fixed. Similarly, the issues of spikes occurring when writing 0 duty cycle was also fixed. PWM UW delay issue. This issue relates to analog write failing in user mode due to delay in setting up permission. Here is a quick demonstration for the PWM fixes. Here you can see the case of writing 0 duty cycle before the fix was made. Spikes in output. Here you can see the after the fix. No spikes in output. Sweeping PWM frequency before the fix was made. Slight disturbances in output. After the fix, no disturbances in the output. The next set of issues relate to standardizing the BoneScript library. These issues come under this section. Supporting node style callbacks. BoneScript now supports node style error first callbacks along with the previous style single object callbacks. TypeScript definitions. BoneScript now has the TypeScript definitions for commonly used methods bundled with the library. Using module.exports instead of exports. The use of exports alias in BoneScript codebase was replaced with module.exports. Interchanging analog and digital function. This issue relates to user being able to interchange analog and digital functions on digital and analog pins. New features available in BoneScript. C module support. BoneScript now supports execution of external C modules without writing separate bindings for them. This gives users advantage of running MRAA examples directly from BoneScript. Remote BoneScript upload. Using this feature, users can remotely upload BoneScript code securely to the board through the built-in BoneScript remote procedure call server. BeagleBone Blue Servo IMU and BMB support. Previously, BoneScript supported peripherals on BeagleBone Blue using Node Robotics Cape library. There were some issues with the library build. Those were fixed and Servo IMU and BMB support was added. BeagleBone user interface shown on the side is a browser-based user interface that can interact with a BeagleBone board, which allows an user without much coding experience to experiment with the onboard LEDs, digital and analog pins through drag and drop buttons on the interface. Currently, the interface supports BeagleBone Black, Green, Blue, Pocket Beagle and also a Pocket Beagle board with the bacon bits cape on it. This is a basic demonstration of the BeagleBone user interface. Hovering over the buttons at the top of the interface will highlight the corresponding pins on the board. Using the button at the bottom of the interface, you can select the type of board if it is not automatically detected. Here is a BeagleBone Green UI. This is a Pocket Beagle UI. This one is a Pocket Beagle board with the bacon bits cape on it. It supports all the features of the Pocket Beagle board along with the RGB LED and the thumb wheel features of the cape. This one is a BeagleBone Blue UI. It supports the user LEDs on the board and the servo and DC motor channels. Dragging and dropping a button on the white rectangle and selecting the corresponding pin will activate the pin, which can be controlled using the slider bar and the buttons. The graph on the right plots the live status of the pins. The buttons under the graph can be used to modify the graph behavior. Here you can see the UI plotting the status of an analog input pin. Here you can see a demonstration of the BBUI interacting with a BeagleBone Blue to control a DC motor and a servo. Thank you.